Okay, let's look at an example using the sound intensity level. Given the equation, the sound intensity level is defined as 10 decibels times the log base 10 of the intensity of that sound divided by that reference intensity, and that the intensity of a point radiating out into space is equal to the power divided by 4 pi r squared. So if I make this approximation, which of course is just an approximation, if I'm talking to somebody, then I'm not radiating those, that sound out uniformly into space, but what the heck, this will be good enough for what we want to do. Suppose that you're talking to a friend of yours at normal conversational level. So your friend is 2 meters away, and the sound intensity level at 2 meters is comfortable conversation. Now, let's call that maybe a little bit low conversation. So let's say, 50 decibels. And again, this is logarithmic. Yes, the pain threshold is about 130 decibels. This doesn't mean we're we're more than a third of the way. It's a third of the way painful. It's not. Power laws crank up over time. This goes up exponentially over time. Now, suppose you think somebody is trying to spy on you and find out what you're telling your friend. And you know that the microphones that those people are using have a threshold of 10 decibels. If the sound is above 10 decibels, the microphone will turn on, they'll record it. Other people will find out what you're telling your friend. You do not want anybody to find that out. So the question is, how far away must you be from the microphone? Now, we're assuming you're talking to your friend 2 meters away. It's the same, you're producing the same, the power is the same thing, it's you. So what you want to do is you have, B of X, where the microphone is located, minus B, 2 meters where the conversation is. That is 50 decibels minus 10 decibels, which equals 40 decibels, which is equal to 10 decibels times the log base 10 of the intensity at X divided by I naught minus the log base 10 of the intensity at 2 meters divided by I naught. Now, this becomes your friend. And if you're familiar with working with logs, it's definitely your friend. But if I have this next equation and say, okay, so 40 decibels is equal to, 10 decibels. So let me divide both sides by 10 decibels. That's equal to the log base 10 of the intensity of that sound at the microphone divided by that reference level minus whoops. The log base 10 of the intensity at 2 meters divided by this. Take a second and pause this because I need to clear this board for my next step. Okay. I've got 4 is equal to, now if I've got log of thing 1 minus log of thing 2, there's a special rule for that. If I have the log base 10, say, of thing A minus the log base 10 of thing B, so that's equal to the log base 10 of A divided by B. So, I have that 4 is equal to the log base 10 of the intensity at position X divided by I naught divided by the intensity at 2 meters divided by I naught. These two reference intensities, they cancel out. And now I'm able to take advantage of the fact that the intensity is power divided by 4 pi times the radius at x squared. That's the intensity at some distance x, divided by the intensity at 2 meters, which is the power divided by 4 pi r of 2 meters squared. And what's wonderful here, what helps us here, is that it's the same noise. So the power is the same, that cancels out. 4 pi is the same, that cancels out. So I've got 4 is equal to the log base 10 of rx squared over a radius of 2 meters squared. Now, okay, if I have that, then if I take 10 to both sides, then I've got 10 to the 4th power is equal to rx squared over 2 meters squared. So I've got rx squared is equal to 4 times 10 to the 4th meters squared, or take the square root of that, and that means that if the other person has a microphone with a threshold of 2 meters, and you're off in a field somewhere, threshold, sorry, of 10 decibels, and you're off in a very, very large field somewhere, floating in space, you need to make sure you're at least 200 meters away from any microphone, or else it will pick up that conversation. Example completed.